All right, so today we're not going to learn anything really too new. We're probably going to learn some new things. We're going to learn about mixing and matching ints and floats and things like that. Mostly what we're going to do today, though, is going to be audience participation. And so what does that mean? That means that I'm going to be calling on people in the class to answer questions. So don't be AFK. I know this is an online class, and every class there's always like two people at the end of class that like aren't there, when I leave. So can't do it this time. You gotta pay attention. All right. So let me do a little bit of lecturing first, I guess, just to get that out of the way, and then we'll do some audience participation stuff. Okay. I don't have a main.cc. Okay, perfect. All right. So then main.cc. All right. So there's rules. Okay. So if you see out 2 plus 5, this is going to do addition. I hope. This isn't a trick question. Everybody on Discord, please print what this will print to the screen. Seven. Very good. Now, the reason why I printed 7 is because we're adding an integer and an integer. Now, what if we add an integer and a double? It's still going to print 7, right? So if I compile this and run it, it's still going to print 7. Okay. But the type of this is now double. Okay, and here's the rule. Here's the learning point for today. Learning point number 1. If you ever mix types in algebra, it widens to be the widest type. Okay? Not the wildest type, the widest type. Okay? So for example, if you add a char plus an int, a char is an 8-bit integer, right? You got a char and an int is 32 bits on our system. Which one has more bits? So if we add a char and an int together, do we get a char or do we get an int? Good. Very good. That's why some of you, when you try doing the thing, try doing like a plus 1, right? You're like, that should be b. And it is, kind of, but we're going to get 66, all right? Because a is the exact same thing as if we had typed 65, right? So, except it's a char. So this is a char, and that's an int, and so when you add them together, you get an int, and when you print an int, you don't get the ASCII code. So if you wanted that to come out as a capital B, you have to cast it, you have to narrow it, all right? So you have to narrow it from 32 bits down to 8 bits. I guess that's a learning point. Not really, but number 2, going from more bits to less bits is called a conversion. And so this is going to narrow from 32 bits to an 8-bit char, and it will print B. Okay. There we go. Now, what if we tried doing this? What do you think? So what is the type if we add, this is a char. Let's actually start off with this. Okay. So we're adding a char and a double together. A double. So here, let's do this. Let's just write the most common types. So we got chars, which are 8-bit integers. We got floats, which are 32-bit floats. And we got doubles, which is 64. Okay. Error? You want to say error if it's on it? So here's the list of like who's more narrow and who's more wide from the types that we know. By the way, strings are not on here. You can't do this with strings. strings don't work with any other. Okay. So 66. All right. 66.0. Actually, just print 66. Now, you are right. It's, you know, sort of like it is 66.0, but when it prints it to the screen, it drops any decimals, unless you like tell C++ to show the decimals. So yeah, so the type of this is going to be double. So the type of that expression here is a double right now. And if we narrow it to a char, then it will be B again. Okay. So if you add an int and a long together, what do you get? Do you get an int or do you get a long? If you add an int and a long, a 32-bit int and a 64-bit int, what is the type of the return value? Good. If you add a float and a double, what's the type of the return value? So if you have, this is a float, that's a double. It equals double. Okay. Okay. Do you guys understand the rule? It's kind of maybe a little bit more advanced C++, but it kind of will help. Because you will probably be a little bit baffled when you're like adding 1 to A and you get 66. You're like, wait, I thought it should be B. Right? And this kind of explains why you were getting 66, which is B, but it's an integer, right? So if you print an integer to the screen, you get the number. If you print a char to the screen, you get the ASCII code lookup. So another place where this comes up a lot is in division. So division will get you. Okay. So if I see out 1 plus 2 divided by 2. This is an integer divided by an integer, and so what's the type going to be? Due to the bit size, yeah, because doubles are wider. They're 64 bits wide, floats are 32 bits wide, and so the result is always the more precise, the wider version. And there is one little bit of weirdness here, where a float, I think, is considered wider than a long. Yeah, it'll be an int, right? And so integers drop any decimal, so 1 plus 2 divided by 2, you would think it'd be like it's 1.5, right? Nope, it's 1, right? So if we do that, we get 1. Okay. So if we wanted to do a floating point divide, we could do that, for example. So if we have an int divided by a double, what do we get? Int divided by a double, what do we get? We get a double. The rule is for algebra, any kind of algebra, it doesn't matter. Addition, subtraction, multiplication, division, it doesn't matter. Modulus is a little weird because you can't do modulus with the doubles. We'll just set that aside for now. So this will give you a double. Okay. And so if you do that, you get 1.5. Okay. Now, sometimes though, people will do this. Double, I don't know, average is equal to 1 plus 2 divided by 2. Okay. Count average. What is this going to print? 1? 1.5? Or 2, maybe? What is this going to print? Okay, so all of you have gotten it wrong, almost. One person got it right. So, what is the type of 1 plus 2? Int. What is the type of 2? Int. It will do integer division here. 3 divided by 2 is 1. It then converts the 1 from int into double. And so it's going to print 1 to the screen. Okay. You don't believe me? 1. Okay. because this is an int divided by an int, so the return type is int. Ints cannot have decimals. It will not be 1.5. And you'll see the compiler is actually very helpfully warning us here. Result of integer division using floating point context, possible loss of precision. Okay? Bug-prone integer division. So it's warning us here. It's like, hey, did you mean to do this? It's a warning. It's on an error. This is valid C++. It compiled just fine. But we're getting a claim tidy error saying you're probably screwing this up here. Yeah. You guys understand? So even though the return type here is double, what's being put into the double is the number 1. And it converts from 1 to 1 as a double. Okay. So that's a little bit of C++ trivia that actually kind of comes up a lot and is actually kind of important. Strings don't work with any of the above. Yeah. So if you have string S with justice, let's do S1 and S2. This is valid C++. You can add them together. So we get justice built. Okay. Can we subtract 2 strings? No. Can we multiply 2 strings? No. Can we modulus 2 strings? No. Can we divide 2 strings? No. The only thing you do with strings are you can add 2 strings together. And it doesn't work with like, you can't like add, like 7 to it or something like that. That doesn't work. Okay. Strings, the only thing that works with strings is that you can add 2 strings together, and that will append them together. Okay, so let's do something. Okay, so we're going to move into audience participation mode. So I will randomly pick somebody to be unmuted, and then you will have to explain to me in plain English what we're doing. So, for char C, S1, plain English, J, what is this code doing? You're on. You're on the air. J. Bajwa, are you there? You muted yourself. You give you 3 seconds. Jay, you there? All right, into the AFK room you go. All right, Jesse Allen. You there?
Yeah.
Good. So, explain to me in plain English, what is this line of code doing? If you had to explain it to a 5th grader, what does that mean in English?
It's charring the string S1. Justice.
Okay, I'm having trouble hearing you. Can you say it again?
Last thing is charring for S1 justice. But just the first one equals 1.
Okay, so the first time through the loop, what is C equal to?
So the char C is equal to.
Okay, I'm going to break the first time through the loop. So what is this code going to print out?
It's going to try and print out just this. Just this is. I'm sorry.
Okay. Don't worry, the previous class is just going to print out the J. Okay.
Oh.
So what this code here means, it's saying for each. This is sometimes called a for each loop, or in C++ it's called a range-based for. Okay. So what it means is for each character in the string, do something with that character. So in this case, for each character in justice, print that character to the string. And so we're going to print the first time through the loop, C is equal to capital J. So we print capital J to the screen. And then we break the loop. So that's why it only printed J. Now if I were to take out this break here, Alan, what is it going to print to the screen now?
If I could print both the J and the B, well, actually no.
The,
Oh, no, sorry.
so the first time through the loop, C is J, right? What is it the second time through the loop?
Then there will be D for the B.
Nope. S2 does not appear anywhere within the code. You can just pretend that Bill isn't there. See how the code still works? That's called a red herring. Okay. Bill does not appear anywhere in here. For each character in Justice. Okay. So the first time through the loop, it's going to print a J and a new line. What's it going to print out the second time through the loop?
If I want print anything, no. If I print out the whole thing for adjusting this time without the.
So the second time through the loop, what is the value of C? What is the value of C the second time we go through the loop? First time through the loop, it was a J. Next time through the loop, what value is C going to have?
It would go to B.
To what?
Or B. Capitalize B.
No, B. It's a red herring. There's S2 doesn't appear anywhere within the code.
Okay, so it's not the U.
The U, very good. And then the third time through the loop, it's going to print out
Yes.
Good. Yeah, and so this is, and it's going to do a new line after each character, right? And so if we run it, we're going to get Justice vertically. Okay. So, all right, very good. Everyone, round of applause to Alan for being tortured. Let's pick on Brendan Sam. All right. Brandon Sam, unmute yourself, please. Hello? You there?
Yep.
All right, let me turn your volume up. You're pretty soft.
Actually, I was just farther away.
Okay. So, let's do some code. If is lower, C, count. Let's actually do this. All right. So what is this code doing? Brennan Sam.
So it's gonna, each time it runs, it's gonna look at the letter,
Uh-huh.
and then if it's a lowercase, it's gonna increase count's value by 1.
Right.
And in this case, it's gonna increase it by 5 times.
5 times, very good.
There's 5 lowercase.
So it's going to print what to the screen at the end?
5.
5, yeah. So the is lower function, everyone, it takes a character as a parameter. It doesn't take a string. It only takes a single character. And returns true if the thing is a lowercase letter, and returns false if it is not a lowercase letter. And so every time this is going to loop 6 times. First time it's capital J, next time it's lowercase u, next time it's s. Each time that character is lowercase, it increases this value by 1. Then at the end of the day, it prints the value out, and we will get 5. Now, what's it going to print this time, Sam?
1? Oh, wait, no. Yeah, 1, actually.
Mm-hmm.
That's what that means, I think.
What about now?
Back to 5.
So is upper, is that the same as is lower?
Is upper.
If it's not an uppercase letter, we increase the count by 1.
So it's the same as is lower, I think.
Is it?
I think so.
You're right for this. Now, what if we make it that? Is an exclamation mark an uppercase letter? Is it a lowercase letter?
No.
So they're not actually opposites, right? So not is lower is not exactly the same as is upper, right? Because there's some characters that are neither uppercase nor lowercase. Does that make sense?
Yeah.
Okay. So if we were to like count how many things are not uppercase, what would we get now?
You get 8.
8. Whereas if we did is lower, how many lowercase letters do we have?
You get 5.
Very good. Very good. Very good. Everyone, a round of applause for Brandon and Sam. All right. All right. Johnny Serna, you're up. You there?
Yeah.
Okay.
Can you hear me?
I can hear you just fine. All right. So let's mix it up a little bit. Let's mix it up a little bit. All right. All right. Before we move on, how many times will this loop run?
It would be 1, 2, 3. I would say 8 times. So it'd be 9 times. Then.
9 times, yeah. There's 9 characters in Justice, right? Exclamation mark, exclamation mark, exclamation mark. There's 6 in Justice plus 3 exclamation marks. So this will run 9 times, okay? And so what if we said if s dot at I is equal to exclamation mark. How many times is this going to print wah to the screen?
It would be 3 times. Since there's only 3 exclamation marks.
Yep. So this is how you grab an individual character out. Where we went from a for each loop to a regular for loop. This is how you grab a character at index I. The first index is 0. That's not exclamation mark. And then checks the U, the S, the T, the I, the S. And then when we get to the first exclamation mark, it's going to print out wah. Then moves on to the next one, moves on to the next one. And we print wah 3 times. Good. Okay. Let me make this harder for you. Okay. What is this code doing now?
It's still doing the same thing because the if statement is still only wrapped around the s1.at_i equals exclamation mark.
Okay, so it's still going to run 9 times. It's still going to check to see. It's going to go through each character one at a time, and if that character is an exclamation mark, what does it do?
Oh, it would change it to a question mark.
Very good. So if we were to output the before and after, it'll go from justice exclamation mark exclamation mark exclamation mark to justice question mark question mark question mark. Okay, very good. Round of applause, everyone. Very good. All right, Romero, are you there?
Yeah.
All right. What is the range-based for loop you're doing?
So for it's making the character for S1, so it'd be J.
First time through the loop, it'll be j.
Right.
How many times is it going to run total?
9 times.
9 times, good. Now we're going to make it doubly nested. Let's make this C1. Okay, so first time through the loop here, C1 is j, right?
Mm-hmm.
Then how many times is this for loop going to run?
4 times.
It's not a red herring anymore. Very good. Okay, and so it's going to, the first time through the loop, C1 is j, C2 is b, right? Capital B.
Mm-hmm.
And they're not equal, right?
No,
So what does it do?
it's false, so it doesn't see out anything.
Yeah, it does nothing, right? Okay, and then the second time through the loop, C2 is I does not match J, doesn't do anything. Third time through the loop, C2 is L. Fourth time through the loop, C2 is L.
Mm-hmm.
Then we move on to the second character of justice, U. Okay, so in plain English, how would you describe what this code here is doing?
So it's comparing the characters in string 1 and string 2,
Mm-hmm.
and if they match, like one by one each character, and if they match, then it prints C1. But if it's false, then it doesn't see out anything.
Okay, so what is this going to print?
See out nothing.
For the whole run.
Yeah.
What characters are in common between Justice and Bill?
I.
So, yeah, you have it exactly right. This code here is finding okay. What about now?
Then it would print and
I didn't hear that. Say that again.
oh, it would print I and L
Okay.
this time.
Let's toss it out to the audience. How many people concurred that it will print I and L? Yeah, technically it will print I and L, but then let's think about this. So yeah, for I, when we get to I, it's going to sweep through all of Bill, and it finds a matching I, prints out I. Then for L, it's going to go through each of the letters in Bill, right? So B doesn't match, I doesn't match, L is a match, so it prints out L. Then it goes to the next L, and it has a match, and it's going to print that out. So if we run this code, you'll see that it's going to print ill to the screen, like license to ill by the Beastie Boys. Okay. So what can I add here, Romero, if I wanted the code to break so that it wouldn't continue on? Like once it found a matching character, we would just be like, all right, that's enough. We've printed it. Let's move on with our lives. So what can I put here to break the loop?
Match just the first character.
Yeah. So like we're going through. We found one L. We're done. We're gonna output an L and then move on with the next letter in S1. So what can I put here to break out of the inner for loop?
You'd put break, but then you'd also have to put
So now prints IL. Okay.
right.
Because we got the first matching L that we break, and then we move on with our lives in S1. All right, I'll give you one more curveball. What is this going to print to the screen? The break only breaks out of the innermost loop. To answer your question, it does not break all of the for loops. It only breaks the innermost one. So Romero, what is this going to print to the screen?
Wait, I didn't really see what you changed. Sorry.
I
Just the string.
swap S1 and S2.
Oh, okay, okay. So would it just print out I?
Okay, let's run through the logic. So the first time through the loop here, C1 is B, and then it's going to sweep through all Justil, not find any B's, and then move on to the next letter in S1, which is I. So we're going to go letter by letter through Justil, and when we find I matches I, it's going to print out I to the screen. And then when we hit break, it does not break this for loop. It only breaks this for loop. So it stops looking through the rest of Justil for any more I's. So like if I put in lowercase e here, none of these are going to be seen, right? Because we're going through, we've got a match. We print I to the screen, and then we break. And when we break, we move on to the next loop in the outer loop. So we're then going to look for the first L in Justil. So it's going to print an L to the screen, right? And then it breaks, and it moves on to the next L in Bill. And it's going to print that as well. So this is actually going to print ILL. You see that?
Yeah.
The break only breaks out of the inner loop. It does not break
Okay.
the outer loop. And so we found a matching L here. And so once we find a matching L, we don't search through the rest of it. But then we move on to the next letter in Bill, and we'll find another L there as well. So we got a match for I, we got a match for L, we got a match for L. Okay. So if you wanted to not allow that to happen, how do I do that? To trim it. Yeah, there's you could like remove duplicate letters and things like that, but that's a little bit more CSI 41. Okay, anyway, well done. Extremely good job, Romero. Well done. Thank you, everyone. Give a rousing applause, please. Okay. So do you guys see why this is going to print ill? The break stops us from finding any more L's in S2. Like I could add, 900 L's here. As we're going along through the inner loop, once we hit an L, it prints it, and then it breaks out, and it moves to the next letter up here. So, yeah, so basically all the extra I's and L's in Justil are effectively pointless, for this loop here. All right, so let's mix it up a little bit. All right, Rafael Garcia, you here?
Yeah, I'm here.
You sound excited. You ready for this?
No.
All right. So let me see if I can make this a little easier on you. All right. How many times is this loop going to run?
Would it be the size of the int you just put? 1, 2, 3, 4, 5, 6, 7, 8, 9, 0?
Mm-hmm. So how big
What?
is that string? How many letters are in that string?
10?
10. Yeah. So the loop is going to run 10 times. Okay?
Mhm.
So first time through the loop, I is what?
I is 0.
So which letter is that index 0 in the string?
1.
1. Yeah. 1 is the first character, also known as index 0. So this is a character. This is not a number. It looks like a number, right? But it's actually the letter 1. This is not the number 1. Do you remember the ASCII table we showed last time?
Yeah.
So the number 1 in ASCII, the letter 1, I should say, is actually 49. Okay?
Okay.
So if I let me just comment that out and just do this. So the first time through the loop, s.i is ASCII 1, right? It's the letter 1, I like to say. So what value is x going to have?
49.
49. So it's going to print what to the screen?
49.
49, yeah. And then what's the next one?
50.
50, yeah, 49, 50, et cetera, et cetera. 0, of course, is below 1. So yeah, we're printing out the ASCII codes of that string. We're actually not, it looks like a number. It looks like we're getting a number. We're not getting a number. We are getting the ASCII codes of the values in the string. So I did something clever, which was to subtract out the ASCII value for 0, which is 49. So the ASCII value for 1 is, 48. The ASCII value of 1 is 49, right?
Yeah.
And the ASCII value of 0 is 48. So what is 49 minus 48?
1. 49 minus 48 is what?
Yeah. And so I'm converting from the letter 1 to the number 1. Do you see that?
Yeah.
And so there's all the numbers.
Mm.
Now, why would I do that? Well, what if you wanted to have a really big number? Can an integer hold that?
No.
What's the biggest number you can hold in it?
9?
Not digits. What's the largest value that an integer can hold in a 32-bit number?
32.
32 bits. So 1 bit can hold either 0 or 1, right?
Uh-huh.
So 2 bits can hold 0, 0, 0, 1, 1, 0, and 1, 1, or 4 values. So every time you add another bit, you can double the number of values you can store. So with 3 bits, you can hold 8 values. With 4 bits, you can hold 16. With 5, you can hold 32. 6, you can hold 64. 7, you can hold 128. 8, you can hold 256. 9, you can hold 512. 10, you can hold 1024. So on and so forth. So about how many values can you hold with 32 bits? $4 billion. So is the number that I have here bigger than 4 billion?
Yeah.
It's a lot bigger. So if you want to have really big numbers, a lot of times you just store them as strings.
Yeah.
Right? And then you do something like this where you pull out 1 digit at a time, and if you're going to be like adding 2 500-digit numbers together, you pull 1 digit out at a time, you add them together, and if it carries the 1, then you carry the 1, and you know what I mean?
Yeah.
Does this make sense to you why we would do something like this?
Yes, I'm just like when it comes to computer science, I think really, really slow. So
Yeah, it's fine. It's
lagging.
you're doing a lot better than my previous class. So
Nice.
yes, but do you kind of get what we're doing here? We're kind of like just printing, like we're converting all of the characters into their corresponding integers.
Yeah.
Okay. So like, what if we wanted to average all of these values together?
Would you use the s dot size of the string s?
Let's do so. Yeah, so we need to get the value of each of these letters, add them all together, and divide by the size, right? Yeah, you're absolutely right. We need the size. So we're going to need to make a variable for like the sum, right? And rather than outputting it, we're just going to say sum plus equals x. In other words, sum is equal to sum plus x. So the first time through the loop, what value is x going to have?
The first time through the loop, x is gonna be 1, right?
1. The number 1.
Like
Not the letter 1. The number 1,
Yeah.
right?
Number 1.
So sum is going to be 1. And the next time
Yeah.
through the loop, x is going to be what value?
It's gonna be 1 plus 2 over.
Yeah, so x is going to be 2. So sum is going to be 3, right?
Yeah.
And then we add in 3, then we add 4, then we add 5, et cetera, et cetera. So this is basically going to add up all of the numbers in this stupidly long number, right?
Mm-hmm.
And then if we wanted to output the average, what did you say about the size?
Would we just divide the sum by the size?
Exactly right. Sum divided by s dot. That is perfect. So if we do this, then the average is 4. Okay. If we want the floating point average, we could make this a double. And then we got 4.08. Okay, does that make sense to you? Why the average is going to be pretty close to 4? So we got a lot of 4s in there. The average, I don't know what just happened there. The average of all this is going to be like 4? 4.5 maybe? It's 10 numbers. Yeah, maybe 5. I don't know. 4.5, something like that. So, 5 maybe. Okay. So yeah, it's not a 10, it's a 0. So, okay. So we're averaging all of the digits together in this. Do you understand?
Yeah.
Okay. All right. Very good. Very good. Round of applause, everyone, for Garcia.
Thank you.
Huh? Let's make this a little simpler. I guess we don't need both sum and count. Series of months. If you want to turn that warning off, by the way, the proper way of doing that is to make this a size t. Size t is a unsigned 64-bit. Use it whenever you compare against s.size. So ints will work. You won't notice any difference, but it'll shut up the warning if you use a size T. That's the proper type. There. Okay, let's see if this works. Okay, so the... Okay. Oh, that's an ASCII code. Okay. There we go. Okay. All right. So I've kind of mixed this up a little bit. I've made a different program here. I forgot that this was an ASCII code, so it was always returning true. I had this, right? I said if s.at_i, and it was always true because the ASCII code for 0 is 48. It's true. And so it was being true for everything. And I was like, why am I not getting anything? So you have to make it a comparison with ASCII code 1 because we're going through every character in the string. So let's pick on Herbert. You there?
Oh, yeah.
Hello. All right. So let's walk ourselves through this code. Okay, you ready for this?
Yeah.
Okay. You sound excited. Are you excited?
Yes.
All right, let's do this. So, first of all, easy question. How many letters are in that string?
Letters?
Yeah. Well, this is the letter 0, the letter 1. Yeah. How many letters are in?
Well, I don't. You want me to count it?
Yeah, it's easy.
Uh.
Oh, wait, I counted it for you.
What?
62. There you go. All right. So, there you go. Easy. I'm printing it for that reason because I didn't want to count
Yeah.
it. So we got 62. We got 62 letters in the string. So how many times is this for loop going to run?
62 times.
62 times. Okay. And so the first time through the loop, we're going to be looking at s.at_0. That is the character at index 0, which is what?
Wait, say again. Sorry.
What is the character at string index 0?
0.
Is it the number 0 or the letter 0?
That's the letter 0, I think.
Yeah, the letter 0.
Yeah, the letter.
Which sounds really weird, but I don't have a better way of saying it, right? Because the number 0 is actually this null character, right? The letter 0 is 48, right? As we saw earlier. Like, it's actually a number, and you can do number things with it. So, all right. So, is s.at_0 equal to ASCII 1 or 49?
No.
Hmm. So do we do anything inside of here? Or do we skip? First time through the loop, do we do the stuff highlighted here, or do we just skip over it? Is this true? For s.at_0. Is it
Well,
true?
I guess since the value of 0 is, since it's the letter, I guess it's not 0, so it's not false, so it's true then. Or no?
So s.at_0 is ASCII code for 0, which is 48.
Yeah.
The ASCII code for 1 is 49. Is 48 equal to 49?
No.
Mm-hmm. So this whole Boolean expression here is false, right?
Yeah.
Okay. So does it do any of the code between the curly braces? No. Okay. So we move on to the next character. And I can make this a really tedious time if you want me to go through every single one of these numbers. But can we just concur that like it's nothing interesting is going to happen until we get here? Okay. So let's say we get here. So we're going to add what to the sum?
1.
What are we adding to the sum? The sum was 0 before. We're about to add something to it.
This is so hard to look at for me. I'm like, yeah, I'm not sure.
What is I when we get here? What is I?
It's one, the letter one.
S dot at I is the letter 1. What is I? This for loop thing here, right? It's starting at, it's the index. Okay.
Oh, yeah.
So we're starting at index 0 and we're going, this is going to be like, I don't know, let's just call it like index 50 or something. I don't know what it is, off the top of my head. So what are we going to add to sum? The location, right? 50, the index.
Wait, so I don't. Okay, I'm trying to understand like what's going on, but
yeah. Well, what exactly this code's doing, we'll get to. But just for now, you understand that I is the index in the string. We're starting at the beginning of the string. We're kind of like sweeping to the right. And so when we get to like, let's say index 50, I haven't counted this. I have no idea what index it actually is. So let's just say 50. When we get to 50, we're going to add 50 to the sum. Okay.
Okay. Yeah.
And then the next time through the loop, I is 51, right?
Yeah.
And then we add 51 to the sum, right?
Yeah.
And we're going to do this like, I don't know, 10 times or so. So we're going to add like 50, 51, 52, 53, 54, 55, let's say. And we're going to count how many of those ones we saw. And then we're essentially doing an averaging of all of those locations. So let's say that the ones are at 50, 51, 52, 53, and 54. And we divide by 5. That's going to give us the average index, the average location that there is a 1 at. So if we have 50, 51, 52, 53, 54, which number is in the middle?
53?
52. 50, 51, 52, 53, 54. So 52 is in the middle. So it's going to see out what to the screen?
52.
52. And so what we've printed is the average location. We're averaging the location of the ones together.
Yeah.
So we're printing out where is the average location for a 1 within the string.
Okay, yeah.
Do you see that?
Yeah.
And so when we run this, we're getting, I don't know, like 56 and a half or something like that. So it's going to be like 50, 51, 52, 53, 54, 55, 6. Yeah, whatever it is. It's going to be like right around, like, if I can select it, like right around here or something, right? It's going to be the average index location, right?
Yeah.
Of all the ones. Now, if I were to put a 1, like, at the beginning, is the result going to go up or down?
It should go down.
Mm-hmm. So the average location is now 51. Dropped quite a bit, right?
Yeah.
And if I slap some more ones in here, then the average should be around 30. Yeah. You see that?
Yeah.
So what we've done here is actually we've calculated the center of mass for the string. So imagine you've got like a stick, and you've got like weights on it. Okay, and the 1 is every place where you have a weight. Okay, what we're computing is the point at which you can balance the thing perfectly on your finger. This is called a centroid computation. Do you see that? So like imagine all these are like weights. Then, if we put our finger at like the 32 mark, then it'll exactly balance between the two sides. Does that make sense to you?
Yeah.
Okay.
Yeah.
Kind of cool, right?
I'm trying to understand like when you would like use this, like,
Well,
or how this can.
I've done center of mass computations a lot. Like the obvious uses are in engineering, right? So you've got a various amount of weights at different places. There's a 2-dimensional centroid. There's a 3-dimensional centroid. which basically tells you where is the center of mass. And once you know where the center of mass of an object is, you can almost replace that object with the center of mass. It makes computations a lot easier, because rather than having like this giant bag that's like all big and complicated, if you know where the center of mass is, then you can just move that around and use the center of mass as shorthand for the entire object. I've used it in neural nets and AI. So you have all these different inputs that are adding things together, and we would do a centroid or center of mass computation from all the inputs to average them together. So, it's programming a dinosaur, and the dinosaur is like, I want to go to sleep, I want to wake up, and different things are going to inhibit and excite different things inside of the dinosaur. We would do a centroid computation to find the center mass for it, to find out what it should do. So these things come up a lot in engineering. Like, it's pretty common in engineering, but like in AI too as well. So, yeah. All right, everyone, give Herbert a big round of applause. Well done, sir. Okay, so so today basically was just a bunch of like demonstration and torturing students to see what you guys understand, see what you get, kind of understanding loops a little bit better. We're going to start a new topic on Friday. Your Zybooks, your next Zybooks is already up, so start working on that. Your times table homework is due on Friday. Mincarelli has said he's going to do a late night study session tomorrow night. I highly recommend not waiting till tomorrow night to start it. Okay, try to get as much of the times table assignment done now by tonight, and then if you get stuck, if there's something that's not working, if you're not passing one of the test cases, you don't know why, then you have time to ask for help tomorrow. But you should roll into tomorrow with like basically either done and passing all test cases, or as much as you can do, so that Mincarelli isn't, fielding questions from people starting tomorrow night at midnight, because that's last minute. And I'm going to sleep early these days. You know what I mean? Like, I'm teaching at 8 o'clock in the morning. I'm not staying up late anymore. So if you're messaging me at 3 o'clock in the morning, probably not going to read it. Okay. Other notes. Nobody's been coming to my in-person office hours. So I'm probably going to move one of them online just to see if we can get more students to show up for that. The office hours are all listed on the syllabus. I'm probably going to transition one of them online. I talked to the in-person class, and I think they would prefer that. They're the ones probably the most likely to visit. Anyway, are you not doing the checker tables? Yeah, so that's what you're going to do for the rest of the lab time today. So we got 10 more minutes in class. I would like for you all to continue working on the doubly nested thing, and then doubly nested practice. And then I'd like for you to, at 3:40, I'd like for you to post your source code. Okay? So that's it for, I'm going to pause the recording now, and then I'll show the answer to this in about 10 minutes. Okay? All right, so I'm pausing the recording now. So start working on your doubly nested practice. Let's continue. I'll just show the answer to this. Yeah, call it for the day. Okay, you can see his BIM is customized. So, undefined reference to get piece application. Interesting. Let's take a look. Let's take a look at yours first. Get piece at location. Probably my guess is you commented it out. Yeah, you commented the actual function out here. So you deleted the function. Yeah, you need to leave this function down here alone. All right. So here is Voss's code here. So first thing you need to do is print the board to the screen. So anytime you have a 2D board, you're going to have a doubly nested for loop, one for each row, one for each column. So we're going to say for every row, for every column within that row, and that'll hit every piece on the board. So the first time through, we're at row 0, column 0. We're going to get the piece at that location, and that's going to either be a W, a B, or a space, which we have very conveniently labeled as white or black or blank. And if it is a white piece, we will increment the white count. Well, so anyhow, this part here ties more into 1 through 3. So the first thing to do is just print the board to the screen. Yes, mouse support turned on. And so basically, we're just going to get the piece and print it, and then when we get to the end of the row, we hit return. And then if we just commented out these 3 things here, then this would be part 0 done. Next, we need to count how many white pieces, black pieces, the blank pieces are on the board. So this is, again, row 0, column 0, first time through. Next time through, it's row 0, column 1. Next time through, it's row 0, column 2, etc., etc. And then it'll, after you finish one entire row, it moves on to the next row, and then does that row, and then moves on to the next row, and does that row. So every time we see a white piece, we increase our count of whites by 1. Every time we see a blank piece, black piece, we increase the black count by 1. Every time we see a blank piece, we increase the blank count by 1. These variables here should be local variables. He probably made them as globals. I wouldn't do that. I would put it here. This is more correct. Nobody else needs to know these variables other than main. So they should be inside of main instead of in global space like that. Okay, yeah, Otal, maybe you commented out your function as well. So, yeah, that looks pretty good, Caesar. That's actually how Voss had originally written his code with multiple calls to get piece of location. You can do it that way. It's extra typing, and it's actually probably a little bit slower. If we save the variable, if we save the result into a variable, then we can just use the variable. It's a little less typing, and it's maybe going to be faster. It kind of depends. And then instead of counter equals counter plus 1, I just go W counter plus plus, right? So basically the same thing, just less typing. Okay. Then after we finish the loop, we're going to print out how many white pieces are on the board, how many black pieces are on the board, how many blank pieces are on the board. That's 1 and 2 and 3 up here. And then the last thing is to see who wins. So you can have no winner, right? If there's like 5 checkers for white and 5 checkers for black, nobody wins. If there's no pieces on the board, there's also no winner, right? So that's something that a lot of students didn't account for, is that I could just give you a erroneous board, right? It's impossible in chess or checkers to have no pieces on the board, but at the same time, you don't want to print white wins because there's no black pieces when there's no pieces on the board. That would be bad coding on your part. So yeah, Dermer, same thing there. It's like right now you're basically, if I handed you a blank board, you'd say white wins and black wins. Everybody wins. You win. You win. You get a card. You get a card. You get a card. Right? And so I would argue that nobody wins if there's no pieces on the board. You know what I mean? So I would probably revise that a little bit. Yeah, otherwise all that looks pretty good to me. It's not really a bug. It's actually more of the programmer mindset that you need to get into. A friend of mine works at Pandora, and his job interview question is essentially this, right? Where he will hand you a board, and you have to say, did white win, did black win? But the test cases he has would have like every piece being white, or like he would give you tic-tac-toe with both 3 X's in a row and 3 O's in a row, and see if you handle it. Right, and so you can't have your code like barf if somebody gives you bad input. You know, you need to be able to handle it, smoothly without crashing and things like that. Yeah, so let's see here. We got Caesar. Yeah, so same thing. Yeah, I would probably just add to that like a little check that if there's white pieces on the board, and there's no black pieces on the board, then white wins. If there's black pieces on the board and there's no white pieces on the board, then black wins. Okay. And you could probably shrink this down a little bit. Okay. So that's the thing. And like I said, this is going to come up in a future homework assignment. For now, you have times table to do. Times table is also a doubly nested for loop. So try and get that done today. And then if you get stuck, you got tomorrow to get unstuck. Okay. So we're going to be starting functions on Friday. Make sure you tune in for that. It's going to be pretty important. And I will see you all then. Peace out. Good job, everyone, today. Peace.